So one last thing I want to just cover in the opening is just a word about MIT and why I think J-WEL is a very natural expression of MIT. And you might say the essence of MIT. Obviously, the goal is to get many, many universities involved, but it's a natural for MIT to take this first step and say, no, learning, real learning, could really be an integrating element cutting across all enterprises, all types of organizations, and really fostering innovation in every single one. You know, you might say creating truly an innovative society based on innovative institutions at all levels. I've been at MIT a long time, and I had the benefit of having, as my mentor for the first decade, one of the kind of iconic figures in MIT's history in the 20th century. His name was Jay Forrester. He led the team at MIT after World War II that built the first general purpose digital computers. He invented core memory, which was the critical technical breakthrough for enabling general purpose digital computation. Prior to that, he had invented radar. And in both cases, not only did he lead the invention, he led the application. So the digital computer project was driven by the need to create a machine-based, this is the language they used to use, a machine-based environment to coordinate the immense amount of data needed to have an integrated North American air defense system. So it was for a very practical problem. That's how he sold it to the US government to fund it. Of course, no one knew what that meant, but he convinced them in the early days of the Cold War that the threats were, everybody knew the threats were growing, and that the amount of data that you needed to be able to organize could never be done by human operators. It all sounds strange today, but in 1946, it was a radical idea. Jay's group not only designed and prototyped the first digital computers, they supervised the construction, the production, and the installation of 28 of them, done by a little company called IBM. That's how IBM got in the computer business. They were installed in 28 sites around North America. And this is a story that makes every engineer's heart open up. I once talked to a Marine colonel who had decommissioned one, when it was ready to be taken out of service. 30 years it had been in service. He said the average downtime was less than a minute and a half per year over 30 years, and they were built with vacuum tubes. Wow. Because the transistor had not yet been invented. So Jay was kind of an engineer's engineer, and I tell all that story because it's the punchline that comes next. I always remember Jay telling that story as a young graduate student. He said, at the end of the 7-year project, and by the way, you can see a whole floor of the Smithsonian Museum in Washington, D.C., the History of Technology Museum devoted to this project. He said, at the end of the 7-year project, we wrote a 4-page paper. So to me, that's kind of so much the essence of MIT. And this is what I kind of internalized from getting to kind of grow up as Jay is my mentor for 10 years. Work on the biggest problems you can. He used to say it takes the same amount of time to deal with small problems as big problems. Why would you waste your time on small problems? Get really good people working together on them. And how do you know you've had success? It doesn't have to do with the papers you've published. It has to do with the impact you've had. MIT's logo has 2 symbols, head and hand. And the idea that learning is all up here is antithetical to the MIT spirit. If you don't do something, if you don't build something, if you don't solve a real problem, then that's not real learning. And it's not what MIT means for learning. That's why I think MIT in some ways is it's just natural to kind of take the lead on such an initiative. I remember years ago, Jay, the last 20 years of his life, he passed away just last fall. He was 99. The last 20, 25 years of his life, he focused on K-12 education. Because he said, I've worked a lot with the adults. He started off working with all these companies like IBM. His students founded digital. So he said, but the adults, it's going to take them a long time. The kids get it immediately. You want to understand systems, go to the kids. They are natural systems thinkers. And then I remember asking him once, I said, well, what would a classroom look like? And he said, classroom, wrong image, don't use classroom. It should look like a laboratory. Kids should be working together on real problems. Doesn't matter what age they are, the problem will be different. But his whole image of the pedagogy, you might say, the design and pedagogy was always informed by this idea that people working together on real problems. And the only thing that will be different if you're a 6-year-old or a 16-year-old or a 26-year-old is the nature of the problem. Because it has to be a problem that's real to you. Um, the last thing about that, which is I've always felt to be the subtlest aspect of the MIT kind of ethos, and it's embedded in that lab image. Because they always call this, in the MIT world, they always call this the labs, as opposed to the classrooms. Because MIT, of course, has lots of classrooms, and then it has labs. The subtle part of that lab culture is the collaborative part. The technology part, the solving real problems part, it's not done until it works. That's kind of obvious in the lab mythos. But it's people working together to solve real problems. And I always found it was really striking when I was a young doctoral student working with Jay, we all worked in teams as doctoral students. What really surprised me is when I would talk to other doctoral students who were working with other professors, none of them worked in teams. They all worked individually, or they just worked for their professor. But no, Jay organized everything in teams. So the whole idea that real learning is not just individual, but it's collective, because people have to work together to solve the toughest problems, is inherent in that lab world. So there's an element of the social emotional learning as well as the technical learning, all subtly embedded in that simple image of the lab. So when Jay said, don't call it a classroom, call it a lab. His image was kids working together on things they really care about. And we've seen so many examples of that in the last 20 years, because there's a whole movement on systems thinking in education inspired really by Jay and his kind of way of thinking. And the first thing you'll always see, you walk into those schools, and they can be 5-year-olds or they can be 15-year-olds, doesn't matter. They're always working together. They're never sitting in neat, tidy rows listening to a teacher. In fact, I have a good friend. It's a project. We're actually have him here as part of a meeting next week, who's an algebra teacher, who's developed a methodology for kids teaching each other algebra. It's brilliant. I've taken so many math educators into his class, and they're just blown away. These kids are all they do is work in groups. The teacher never talks more than 5 minutes in any class. Sometimes he doesn't talk at all. And the kids just go to work, and they're all helping each other solve very complicated algebra problems together. And so this integrating of the social, emotional, technical, or the social, emotional, systemic into one integrated learning process is really inherent in that lab image, but it's subtle.